Dear viewer, it's a video on the topic Zeroth law of thermodynamics. If you are interested, sit relaxed, make yourself comfortable, watch, enjoy, and learn. Over to the topic now.
Thermodynamics. To study zeroth law of thermodynamics, first we will define what is thermal equilibrium. In order to define thermal equilibrium, one must be familiar with the term temperature. This temperature is a measure of hotness or heat content. And for heat transfer to take place, there must be a temperature difference. And heat always flows from a body at higher temperature to a body at lower temperature. Now, to study thermal equilibrium, consider two bodies. Body A at 80 degrees Celsius and body B at 30 degrees Celsius. Suppose if these two bodies are brought together and separated from the surroundings, after few minutes, the temperature of these two bodies change and they will reach a thermal equilibrium. Now, what is this thermal equilibrium? It is the condition at which there is no heat transfer. At thermal equilibrium, there is no heat transfer from body A to body B or vice versa. Remember, temperature difference is the driving force or the potential, and heat transfer is the flux. So temperature difference is the driving force. Temperature difference 45 degrees Celsius minus 45 degrees Celsius, which is equal to 0. Driving force is 0 therefore, and hence no heat transfer between body A and B when thermal equilibrium is reached. But initially, the driving force is 80 degrees Celsius minus 30 degrees Celsius, and hence heat is transferred from body A to body B. Because of that, temperature of body A decreases, correspondingly the temperature of body B increases, and they reach an equilibrium 45 degrees Celsius at 45 degrees Celsius. So at thermal equilibrium, there is no heat transfer. That means heat content of the systems are equal. Heat content of the systems are equal. How do we know heat content of the systems are equal? Or in other words, what is the condition for thermal equilibrium? The condition for thermal equilibrium is equality of temperature. So two bodies are said to be in thermal equilibrium when they are at the same temperature. Now we will focus our attention to zeroth law of thermodynamics. It states when body A is in thermal equilibrium with body B and also separately with body C, then B and C are said to be in thermal equilibrium. So when body A is in thermal equilibrium with body B and also separately with body C, that means body A is in thermal equilibrium with another body C, then that C and B are said to be in thermal equilibrium with each other. So this is what zeroth law of thermodynamics. To explain this, consider two bodies A and B are in equilibrium at the temperature 45 degree Celsius. Here we have two bodies. Where is the third body? So the third body here is thermometer, is a thermometer. So this body C is in contact with body A alone, not with body B. Suppose if the thermometer reads a temperature of 45 degrees Celsius, suppose if the thermometer reads a temperature of 45 degrees Celsius, then we can say body C and body B are in thermal equilibrium. So the same thing can be explained with body A, body B separately. So here a thermometer is inserted in body A and a thermometer is inserted in body B. Right now, we don't know what is the temperature of body A and body B. Right now, we don't know what is the temperature of body A and body B. And if the temperature of body A and the temperature of body B read by the thermometers are equal, then we can say body A and B are in thermal equilibrium even though they are not in contact, So that is what represented here. Two bodies A and B are in thermal equilibrium if their temperature is same, even if they are not in contact. So there is no contact between body A and B. We don't know the temperature initially, but when you measure with a thermometer, and if both the bodies represent or shows the same temperature values in the thermometer, then they are in equilibrium. So this is what zeroth law of thermodynamics. Now, to measure this temperature, we need temperature scales. To measure temperature, we need temperature scales. A temperature scale is based on certain reference point. So what is that reference point? Reference point are reproducible state. Example for reproducible state are ice point and steam point. What is that ice point? Ice and water. So ice point is a one at which ice melts or water freezes. And the other one is steam point. What is that steam point? Consider a vessel, spherical vessel, and it is filled with water. If you add heat to this water, after a few minutes, steam will be generated, and that occupies the space above the water. So what is that steam point? It is the temperature at which water is converted into steam, or steam condenses back into water. So thermodynamic temperature scales use these reference points, ice point and steam point, and these scales are the scales widely used are Celsius. Ice point 0 degrees Celsius, steam point 100 degrees Celsius. So the 0 and 100 are arbitrarily assigned in Celsius scale. The other one is Fahrenheit. In Fahrenheit, ice point is arbitrarily assigned a value of 32 and steam point 212. So the Celsius and Fahrenheit are used widely in commercial applications. Even during health checkup, we use Fahrenheit. But in the subject thermodynamics, we need a temperature scale which is independent of the properties of the substance. So what is the properties of the substance? Ice point, arbitrarily we are assuming 0 degrees Celsius, that is at one fixed pressure. Suppose if the pressure of water is not equal to 1 atmospheric pressure, the value of ice point will differ. Similarly, boiling point of water at 1 atmospheric pressure is 100 degrees Celsius. If the pressure is not equal to atmospheric pressure, then the boiling point or the steam point is different. But we need a scale which is independent of the properties. The property we discussed now is pressure. So the scale used in thermodynamic subject is Kelvin. And Kelvin used triple point of water as the reference. What is this triple point? At triple point, ice, the solid, water, liquid, and water vapor. So in vapor form, exist in equilibrium. Solid, liquid, and vapor exist in equilibrium. That is what a triple point. And what is the relation between Celsius scale and Kelvin? Just add 273.15 to Celsius. That gives you temperature in Kelvin. An ideal gas temperature scale is nearly identical to Kelvin scale. And remember, at low pressures, temperature of gas is proportional to its pressure at constant volume. That means we know PV equal to RT. What is the assumption here is mass is equal to 1 kg. That means unit mass. And when V is constant, pressure is proportional to temperature. Pressure is proportional to temperature, or temperature is proportional to pressure. A constant gas volume thermometer would read minus 273.15 Kelvin, which is nothing but absolute zero temperature at absolute zero pressure. It is vacuum. Remember, all the pressures we measure are not absolute. We are measuring the pressure with respect to the atmospheric pressure called gauge pressure. So gauge pressure tells you the difference between absolute pressure and the atmospheric pressure. Absolute zero pressure means complete vacuum.
And now the takeaways in the lecture, Zeroth law of thermodynamics. Zeroth law of thermodynamics provides the basis for temperature measurement. Of course, measurement of temperature helps determine the equilibrium of two bodies. And the temperature scales used are Celsius, Fahrenheit, and Kelvin. Kelvin Kelvin is the SI unit of measurement. Kelvin uses triple point of watt as the reference, which is independent of properties. Whereas Celsius and Fahrenheit scales use ice point and steam point of water as references, which are dependent on the property of the substance. Thank you.